Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Aisyah binti Megat Syaiful. My student ID number is 2020891704 and I'm from JCS1433E.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ilya Iklima binti Muhammad Yusof and my student ID is 2020610654.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farah Izzati Natasha binti Mahathir. My student ID is 2020808872 and I am from class JCS1433E.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Aina Syaira binti Zubahrin.
So firstly, I'm going to tell you about mathematical terminology in content. So in dealing with proofs, there are 4 terms that you will come across. A mathematical proof, which is a list of statements in which every statement is one of the following. It is firstly, an axiom. Second, it derived from previous statement by rule of inference. Thirdly, a previously derived theorem. So let's go back and have a flashback. What is an axiom in math? In mathematics or logic, so an axiom is an unprovable rule or first principle accepted as true because it is self-evident or particularly useful. For example, of axioms can be 2 plus 2 equal to 4, 3 times 3 equal to 4, and etc. While in geometry, we have similar statement that a line can extend to infinity. This is an axiom too because you do not need to prove to state it's true as it is evident in itself. So there are 4 levels of hierarchy of terminology. Firstly, a proposition is a mathematical statement such as 3 is greater than 4, which is an infinite set exists, or 7 is a prime. Secondly, a theorem, which is a statement that has been proven to be true, such as if 2 lines intersect, each pair of vertical angles are equal. Thirdly, a lemma. A lemma is a true statement used in proving other true statements. That is a less important theorem that is helpful in the proof of other results. So fourth is a corollary, which is a true statement that is a simple deduction from a theorem or proposition. Next, construction method. So what is construction method? When proving that A implies B is true, suppose you obtain a statement in the forward process that has the quantifier there is in the standard form. A, there is an object with a certain property such that something happens. Object, certain property, something happens. Thus, you can assume that there is such an object, say, let's say X, this object X together with its certain property, and the something that happens should help you reach the conclusion that B is true. In contrast, if you encounter the keywords there is during the backward process, then you must show that B, there is an object with a certain property such that something happens. One way to do so is to use the construction method. The idea to construct, guess, produce, device an algorithm to produce and so on the desired object. The constructed object then becomes a new statement in the forward process. However, you should realize that the construction of the object does not by itself constitute by the proof. Rather, the proof is complete by when you have shown that the object you construct is in fact the correct one. That is, that the object has the certain property and is satisfy the something that happens, which becomes the next statement in backward process.
So for the example 1, the question is prove that there is an integer x such that x squared plus x over 2 minus 1 over 2 equals to 0. So is the constructed object unique? So we can analyze the proof based on question. A is x square plus x over 2 minus 1 over 2 equals to 0. That is hypothesis. B is there is an integer x. That is conclusion. So A1, we can get A1 from conclusion from A. We can get 2x square plus x minus 1. Then A2 is x equals to 1 over 2 or x equals to negative 1. That is by factoring A1. So A3 is x equals to negative 1 is the only integer solution for the quadratic equation. That is negative 1 because 1 over 2 is not the integer, so we can take the negative 1. So we have found the proof because we can because A3 is equals to B, there is an integer x, so we can find the integer. So A3 is the end of the proof. So for the condensed proof, for this question is given a quadratic equation a square plus x over 2 minus 1 over 2 equals to 0. By factoring the equation yields the values of x equals to 1 over 2 or x equals to negative 1 is the only integer solution for the quadratic equation. Thus, the constructed x is unique.
So I will explain how to answer two questions using construction method. For example 1, the question is there exists a positive real number x such that x cubed minus 3x squared minus 9x minus 5 equal to 0. Are the constructed objects unique? It clearly shows that it's B. Why? Because it started with there exists. And the question asks are the constructed objects unique? Unique means the final answer will only have one value, while if the answer have more than one value, it's called not unique. So B, there exists a positive real number x such that x cubed minus 3x squared minus 9x minus 5 equal to 0. A1 equal to x cubed minus 3x squared minus 9x minus 5 equal to 0. We get x minus 5, x plus 1 equal to 0. And then x equal to 5, x equal to 1. A2 equal to x equal to 5, x equal to 1, the element of real number. So the conclusion, we can say that x is not unique because it have two values. Next, for example 2, the question is, if p less than q are consecutive integers and q is odd, then 2 divides 3q squared plus p squared plus 1. A, the hypothesis is p less than q are consecutive integers and q is odd. B equal to 2 divides 3q squared plus p squared plus 1. B1, there is an integer p such that 3q squared plus p squared plus 1 equal to 2p. A1 equal to p equal to m, then q equal to m plus 1 for some integers m. A2 equal to 3q squared plus p squared plus 1 equal to, we substitute the value, 3m plus 1 square plus m square plus 1 equal to 3m square plus 2m plus 1 plus m square plus 1 equal to 3m square plus 6m plus 3 plus m square plus 1 equal to pm square plus 6m plus 4. The final answer is 2m plus 3 plus 4. A3, 3q square plus p square plus 1 equal to 2p, where p equal to m, 2m plus 3 plus 4. Okay, the conclusion is same with B1.
Next example for construction method, the question is if n is an integer and n is an odd integer, then n squared plus 3 is divisible by 2. Firstly, we must declare the hypothesis and conclusion, A for hypothesis and B for conclusion. From this question, the hypothesis is n is an integer and n is an odd integer, and the conclusion is n squared plus 3 is divisible by 2. The key question is how can we show that n squared plus 3 is divisible by 2? For B1, there is an integer r such that n squared plus 3 equals to 2r. From A, it is said that n is an odd integer, so in A1, I let n equals to 2b plus 1. Then in A2, substitute n equals to 2b plus 1 into the equation in B. So it will become 2b plus 1 square plus 3. Expand the equation until get 2b squared plus 4b plus 2. Next, factorize the equation so that it will be 2r, where the r is equals to b squared plus 2b plus 2. So from here we can see that statement in A2 is equivalent to B1. Next example, the question is, if the function fx equals to square root x plus 1 is continuous in the interval 0, 3, then there exists a value c that satisfies the mean value theorem for integral. We declare the fx equals to square root x plus 1 is continuous in the interval 0, 3 as a hypothesis, and there exists a value c that satisfies the mean value theorem for integral for b conclusion. The key question is, how can we show that there exists a value c that satisfies the mean value theorem for integral? For b1, there exists c between 0 and 3. Next, in a1, we must use the formula of mean value theorem for integral. In a2, substitute all the information into the formula. Solve the equation, and at the end I get c equals to 1.42, where it is between the interval 0 and 3. So we can see that the statement in A2 is equivalent to B1. That's all from me. Thank you.
Lastly is the conclusion. From what we have presented, I've concluded that question, how important are terminologies and constructed method in learning mathematical concepts? Well, it is important for children to use correct mathematical vocabulary and have an understanding what this term means. This technique of working with such as object, simply before a student can start to solve a problem, they must find understanding the problem first, right? So understanding can take many forms, but the most basic is understanding the language used. Second conclusion, mathematical logic is to sharpen the logical and analytical skills of a student, as these are necessary for the understanding and learning of mathematical proofs. Well, mathematical logic through is characterized by its symbolic presentation form and formal rules. Mathematics, on the other hand, combines mathematical symbolism and natural language, and its methods are rigorous yet less formal.